So the base could also be a triangle. So I'm gonna kind of draw it like that and connect it. This would be a triangular prism. Same formula. So you see how important it is to know how to do capital B? Because all of the figures we've done so far use the same formula. Cylinder, hexagonal prism, triangular prism. They all are capital BH, but they're solved very differently because the base is a different shape. So what shape do you see the base is here?
A triangle.
Yep. So our capital B is going to turn into 1/2 lowercase bh, the formula for area of a triangle.
Oh, so the other two were uppercase B's.
The other two didn't have a lowercase b, they had radius. The cylinder had
Oh,
radius. The hexagon had a lowercase a, capital P for
oh,
apophthegm perimeter. So yeah. All right, so let's say I tell you the height of this triangular prism is 20 inches, and I tell you that the triangle has it could now here's the thing with the triangle. They could give you the little base and the height, but like that would be too easy. You want to be able to do challenging questions because if they give you, oh, the height of the triangle is this, the base is this, you're gonna be like, oh, that's super easy. So I want to show you one where the base is an equilateral triangle, because if you know how to do that, you'll know how to do everything else. So let's say the base is an equilateral triangle. So that let's say it's 10, 10, and 10. Okay. Now, we have to use this formula, A equals 1/2 BH. What is the height of, let's start with the base. What is the base of that triangle?
30.
No, that's perimeter. What's the base?
Oh, 10.
Yeah, 10. So we know what our lowercase b is. Notice this is a lowercase b, so it's just one dimensional, it's not area. And what is the height of this triangle?
Is it 20 or
Mm.
no?
So
Is it also
height, say that again?
is it also 10 or no?
No, because the sides that are 10 are slanted. Height always connects the highest point to the base with a perpendicular line. Height is perpendicular to the base. The height must be perpendicular to the base. So the height is unknown here. We don't know what the height is. We got to figure it out. So if we split an equilateral triangle down the middle through the height, what shape do you notice forms?
A
What
right
shape?
triangle.
Exactly. Now, right triangles show up everywhere in places you would not expect, even in cylinders and prisms. So, anytime you see a right triangle, be like, Pythagoras, where are you? So now this side is still 10. What is the length of this side?
5.
hmm Now, what's true about equilaterals? All the angles are 60 because triangles have to add up to what?
180.
And since it's equilateral, all the angles are also the same. So equilateral is automatically equiangular. So 180 divided by 3, all the angles have to be 60. So this angle here is 60. But what is this angle?
30.
What kind of triangle do you see?
30, 60, 90.
Yes. So now we use that to our advantage. What are the proportions or what are the side lengths of a 30, 60, 90?
Um, eggs, um, um, x, square root of 3,
Mm-hmm.
and then 2x.
Good. We already have our 2x and our x here, 5 and 10. So what is this side?
Um, 5, 5,
Mhm.
square root of
That's
3.
our height. So our height is 5 square root of 3. So we're going to do 1/2 times 10 times 5 square root of 3. Half of 10 is 5 times 5 square root of 3. We got 25 square root of 3 as our area. That's our capital B. But now we got to go back to volume. So volume is capital B times H. Now, here's the tricky part with prisms. Don't think of height as standing up because a lot of students get tricked with that. In a prism, the height is not just from the highest point to the bottom, right? So some students might think, oh, the height is 5 square root of 3 because that's the distance from the top to the base. No. In a prism, the height is the distance between the bases. So the height here goes from one base to another. So the height goes from this base to the other base. It's that distance between. So what is the height?
20.
Yep. And we're doing inches. By the way, we didn't keep track of our units. The area of the base is inches squared. And this is inches to the first. So now we're going to do 25 times 20, which is 25 times 50 plus the other 0. 500 square root of 3 inches cubed is our volume.
Miss Hannah, how do you get inches, centimeters?
They give it to you.
Oh, okay.
Yeah, just keep track of. Just remember volume is to the third. You're not actually raising anything to the third power. We're just writing the 3 for the units, labeling it. But we're not actually raising anything to the third power. Not here, at least. All right, and then also get used to turning it into, when you're practicing this, to a decimal, just so you can practice your rounding. Go ahead and do 500 times square root of 3 and tell me what you get.
I get 866.025.
Okay, so I want you to round to the 10th, 100th, and to the nearest cubic inch, which would be ones place. Good. So for the 10th place, 866.0. As we looked next door, it was a 2, so it stayed 0. For the hundredths place, we look at the 2 and look next door, it's a 5, so it turns into 3. And cubic inch is the ones place. We look next door, it's a 0, so it stays 6. Okay, another interesting little figure you might see is a square prism, which is actually just a cube. Because the base is a square and then you're connecting it. It's just a cube. So we have a cube here. What is special about a cube?
All of the sides are like squares.
All the sides are square. The faces, we call them
Spaces are
faces. Yeah. And the edges are all the same. So like if this is 2 centimeters, length and width are both 2 centimeters, and then the height is 2 centimeters. So we could do length times width times height, but the length, the width, and height are all the same. So a lot of times you'll see variables being used. S times S times S, S to the third. So a cube, the volume of a cube is the side, the length of a side to the third
Mhm.
power. So here the volume would be 2 to the third, which is 8 cubic centimeters.
Oh, okay.
Quick. Okay, speaking of Pythagorean right triangles, sometimes you have to use Pythagorean theorem. So like, let's say you have a cylinder. Sometimes they'll give you like the diameter, let's say, and they'll tell you the length from like the diagonal inside the prism. So let's say this is 5 inches and let's say this is 4 inches. but they won't give you the height, and they ask you to find the volume of the cylinder. Well, you would look on your formula sheet. The only formula for volume of a cylinder that they give you is V equals capital BH. But since it's a cylinder, what's capital B going to be?
Capital B is going to be the radius.
No.
Eh, nope.
Capital B means area of the base. What shape
Oh
is the
yeah,
base?
cylinder with a circle. So
Mm-hmm.
4 to H. So pi r square.
Good. So now we do capital B pi. What's the radius?
2.
So B equals 4 pi. So now we go back to the volume formula because that's what we really want. V equals capital B, which is 4 pi times the height. But the height is missing. They love to do that on the test. Something you need is missing. So you have to do an extra step in a different process to get the thing you need. So we're like, how in the world am I going to get the height? Well, if you notice, what shape do you see inside of the cylinder?
A right triangle.
Exactly. Anytime there's a right triangle, check to see if it's a 30, 60, 90, a 45, 45, 90, or if you can use trigonometry, or if you can use Pythagorean theorem. So anytime there's a right triangle, there's four things you can do. You can either use Pythagorean theorem. You can use Pythagorean theorem if they give you at least two sides and you're trying to find the third side. You can use 30, 60, 90. If you know the angles are 30, 60, 90, you can use that pattern. The x squared of 3, 2x. You can use 45, 45, 90, which is x radical 2. Or you might have to use trigonometry, which you also have those formulas on your sheet. The sine, cosine, tangent. Okay, in this
Mhm.
case, which of the four do you think we have to use?
Pythagorean theorem.
Yeah, because we know two sides. The hypotenuse is 5, and one of the legs is 4. So we're going to do a squared plus b squared equals c squared. Okay, your c is always across the 90. That one has to be 5. Your a and b are interchangeable. It doesn't matter where you plug it in. I'm just going to make this a and b. So 4 squared plus b squared. Any questions so far?
Mm-mm.
Okay, so we get 16 plus b squared equals 25. Subtract 16, we get 9. So what is b?
9.
No,
Oh,
b squared is 9.
B
What do we
squared.
have to?
Oh, 3.
Yeah, we have to square root 3. So then our height is 3. Now, I did Pythagorean theorem, but if you are familiar with Pythagorean triples, you would have saved time. You didn't even have to do Pythagorean theorem. So if you memorize your Pythagorean triples, there's a bunch of them, but if you know even just one of them makes a difference. A 3, 4, 5. So if the legs are 3 and 4, the hypotenuse will always be 5. So sometimes people like to memorize that, a 3, 4, 5, because it kind of speeds up your work. Because I'm like, oh, the hypotenuse is 5, and one of the legs is 4. The other leg has to be 3. I don't even need to do Pythagorean theorem.
Mm-hmm.
That's called a 3, 4, 5. And any multiple of 3, 4, 5 is also a Pythagorean triple. So if I multiply each side by 2, a 6, 8, 10. So if the legs are 6 and 8, I already know automatically the hypotenuse has to be 10.
Oh,
So that saves time. But if you don't have to know those, you could just do Pythagorean theorem. So now we have 4 pi times 3. And this 4 pi was inches squared because it was the area of the base. And the 3 is inches. So we get 12 pi inches to the third. So that's our volume.
that was the easiest one.
Okay, so this is a quick example of like a real world problem. You have a tree. Let's say you want to experiment with the tree, like how old is the tree? What's the radius of the tree? What is the area of the tree stump face? Um, and you don't want to cut the tree down, right? So
Mhm.
then they decide to put a string around the tree and they say, oh, the whole string around the tree measured 100 centimeters squared. What is the area of the cross section? In other words, if I cut the tree open in that same spot where I put the string, what's the area of that flat circle face, right?
Mhm.
So what would you do? What are your thoughts? Okay, I'm
So,
glad you said that. So you that's very good that you said that, right? To find the area, you need the area formula. So let's write that down. Area of a circle. What's the formula?
pi r squared,
Okay, what do you need to be able to calculate the formula?
your radius.
But do you know the radius? Was it given?
No.
No.
Well,
So we need radius. We don't have it. Can we find it out somehow?
yes.
How?
So since it's 100 centimeters, we equal 100 um to our um pi r square, and then
Is
you
100 the area?
no.
Oh, I shouldn't have made this squared. Let me fix that actually. Because the string is one dimensional. Does a string have height?
Oh no.
A string is just length, right? So
Hmm.
actually, this should not have been to the second power. Okay. So 100 is not the area. So we can't do 100 equals pi r squared. 100 is the length of the string around the tree. So what do you think that represents?
The length.
The length around a circle has a special name. If it was like other objects, we call it perimeter. But for circles, it has a special name that starts with C.
Circumference.
Yep.
Okay.
Anytime you measure the distance around a circle, it's circumference. So when you put that string around the tree, that's circumference. What's the formula for circumference?
Um, there could be two pi r
Mm-hmm.
r.
Good. 2 pi r or pi d, but this was, we want to use 2 pi r because we want the radius. So we do 100 equals 2 pi r. Now we can solve for radius. How do you get r by itself?
We divide two pi by two.
To both sides. So radius equals 100 divided by 2, 50 over pi. That's your radius. I'm going to leave it like that because it might help with canceling stuff out when we plug it into radius. So into the radius of the area formula. So now r equals 50 over pi. So we're going to go back to the area formula now because now we know the radius. 50 over pi to the second. That equals pi what times 50 times 50, 2,500 divided by pi to the second power. If we multiply that, we can put this pi over 1. We get 2,500 pi divided by pi squared. One of the pi's on the top cancel with one of the pi's on the bottom because we have pi times pi on the bottom. So this cancels, and our final answer is 2,500 divided by pi. That's the area. An area is to the second power, so it would be centimeters squared.
Okay, so whenever they give us like circumference, we use the circumference formula to find the radius.
Yeah, sometimes like you can use circumference to find area and you can use area to find circumference because both of the formulas have radius in them. So you can like use each formula for each other.
Mm-hmm.
Okay, since it's a real world problem, we most likely would not leave our answer like this because it doesn't make sense. If I tell you the area is 2,500 divided by pi, you're like, yeah, but what is that? Like, if I have to get a ruler, if I have to like measure something, like pi is a decimal that goes on forever. So since it's real world, we're going to do 2,500 divided by 3.14. We want to actually get a final answer, not just leave it in terms of pi. So now we have 796.178. And then the word problem will tell you how to round. Let's just round to the nearest square centimeter. What would the final answer be?
Squares. 6,
Mm-hmm.
7, 9, 6.
796 square centimeters would be our area.